Yeah, hi, good morning everyone. So, shall we begin the session? In the last class, we have finished with the chapter number 7, that is the detailed design, and the today's topic is chapter number 8, system control and the quality assurance. That is, what are the various system control methods and how we can ensure that there is a quality assurance, or how we can ensure that quality will be monitored and maintained as per the requirement of the user. That is the quality assurance. This is the today's topic, that is the system control and the quality assurance. That is chapter number 8. And these are the multiple topics that we are going to cover within this chapter. The first one is introduction. Sorry, objective. Then there is an introduction. So these are the various topics that is covered in this chapter, chapter number 8. First one is the objectives. Then introduction of the chapter, introduction of the system control and the quality assurance, that includes the system or design objectives, why we are relying on this system, or what are the various considerations, what are the various factors, why we are approaching that system only, that is a reliable system. Then error avoidance, how to avoid the errors, then error detection and the correction. So first of all, we have to detect the error. What are the various error that is covered, or that occurs within the project, whether that may be a testing error, that may be a application error, what type of error is this. So that is error detection and the correction. Then we also focus on that the error will be avoided. The reason is, if the error comes, then there is a lots of process that will take place for the testing. That means, first of all, check the status of the testing, whether the testing engineer is available or not. It takes a lots of time in the system maintenance, in the system control. So we have to do the things so that the error will be avoided. That is error avoidance. But in case the error occurs, because it's a human being that doing the job, so error. Yes. Yes, errors. If the errors occurs, then there is error prevention methods, error detection methods, bugs removal method. Everything is available. Then what are the various causes of error? Why the error comes? That may be a syntactic error, that may be a logical error in the programs. What type of error this is? Then maintenance of the system. How to maintain the system? What are the various category by which we can maintain the system? Either to upgrade the technical things, either to maintain the technical things. The next one is software design. How to design the system, whether to follow the bottom-up approach or the top-down approach. So first one is the top-down structure of the module. Then there is a coupling and cohesion. These are the very much important topic, that is the coupling and the cohesion. This denotes that how two modules are related with each other, or how the system components are related with each other. That is the coupling and the cohesion. Then the span and control, or that is what are the various categories by which the controlling is done. That is span of control. Then module size. What is the module size that is appropriate for the system design, for the system maintenance? Then shared module. What are the various shared module by which we can occupy, by which we can get the methods? The next one is the software design and the documentation tools. What are the various software design methods, and what are the various documentation tools that will be occupied in the software design and the documentation? First part is a structured flow chart. The next one part is the HIPPO. That is a hierarchical input output, or input process output. Then what are the various table of contents? Then Vernier or diagrams. Then managing the quality assurance. What are the various quality assurance? Then what are the various levels of assurance? That is the testing, verification, validation, and the certification. That is the ISO certification. The next one is the testing plans. Next topic is, what are the various testing plan? What are the types of testing, or how we can test the error so that the error will be removed. So first one is a code testing, then specification testing, managing the testing practices. Now what are the various levels of test? Then unit testing, integration testing, and spatial system test. Then after this, 8.8 is designing the test data, then testing the libraries, system controls, audit trails, and the summary. So these are the few topics that is covered in this one. So let's begin with the objective. What is the main objective of studying this chapter? So the first one is the goal of the quality assurance in the system process or system development process. So goal of the quality assurance is one of the main objective. The goal will be achieved for the quality assurance in the system development process. Then what are the system design objectives? This is also the objective of this chapter. And this we are going to study that what are the various system design objectives. Then what are the various software design and the documentation tools. So categorize the software design in the documentation tool that is available for the software design. Then why systems are tested. So why there is a requirement for testing the system, that is why systems are tested. Then the activity network of the system design. Then what steps are taken to test the system. So what are the various steps that is taken to test the systems. Then what is the audit trail. So these are the various objectives of this chapter. We are going to study this chapter. So first part is the introduction. First line is saying that no program or system design is perfect. As I said, because everything is doing manually by the developer, by the system designer, by the system analyst. So that is a human being. So no one is perfect in terms of the designing, in terms of the development, in terms of the analysis. So no program or system design is perfect. And so communication between the user and the designer is not always complete or clear, and the time is usually short. So whenever there's a system designer, whenever there's a system analyst that takes a requirement from the user that is not accurate at all the times, and for developing the system, time slot is also very short. Due to this, the results are errors. That means the output of this one is errors, bugs that occurs in the system design. And the number and the nature of the errors in a new design depends on the multiple factor that is given below. What are the various factors why these error comes or why these error occurs in a new designing phase? First one is communication between the user and the designer. So if the designer is capable of getting the requirements of the user, then everything is perfect. But there is a communication gap, there is a loophole between the communication or between the user and the designer. So there is a communication gap between the user and the designer. Next one is programmer's ability to generate a code that reflects exactly the system specification. If the requirements are okay with the designer, that is system analyst, then next part is the programmer's ability, whether the programmer that is available that is used to generate the code that reflects exactly the system specification, everything is okay with the system specification or not. So these are the two errors. One is from the system analyst, one is for the designer end, that is the system analyst, one is from the programmer's end. And these factors puts an increasing burden on the system analyst to ensure the process of the system development. Because everyone or everything is responsible for everyone or for everything. So for everything, the system analyst is responsible. So system analyst must ensure that the success of the system be developed for increasing the burden on a system. So the quality of a system depends on its design, development, testing, and implementation. These are the four factors. So we have to focus on these four factors on these four stages if we want that there is no error in the system. What are the four phases? What are the four parts? One is the system design, one is development, testing, and implementation. Next part is the design objectives. What are the various objectives? Why we are designing the system? So the two operational design objectives that is used by the developers are the system reliability and the maintainability. That rely on the system, that is the reliable systems, and there is a maintainability in the system. That may be a technical maintainability, technical upgradation, that may be a logical upgradation, there may be a coding upgradation, whatever. A system is said to be reliable if it does not produce dangerous or costly failures when it is used in a reasonable manner. So when we say the system is reliable, if it does not produce the dangerous or the costly failures, that means it does not include the costly failures or the dangerous failures when it is used in a reasonable manner. That is in a manner that a typical user expects is normal. So we expect the output as a normal, then only we say that the system is reliable. Yes, tell me the error, Joseph. No, I'm saying that the system is reliable if it does not produce any errors, any failures. Then we say that system is reliable. But as we said or as I said in the first line, that no system is perfect, no program is perfect. So how it is reliable? But for making the system reliable, we have to focus on the testing, development, and design and the implementation phases. Now, there are the changes in the way users use a system and also in the business operation. So there is a communication gap between the user and the developer, user and the designer. So there are the steps the analyst can take to ensure that the system is reliable when it is installed and that the reliability can be maintained after the implementations. So various steps are also followed for making the system reliable, and so that there is no maintenance cost, so that everything is reliable, or we focus on the reliability of the system, or the communication gap is also removed. That is also one of the feature of the reliable system. So what are the various approaches to the reliability? There are two levels of reliability. The first is the system is meeting the right requirements. So first part is to check whether the system is meeting the right requirements or not. For example, system might be expected to have a specific security feature of the control built into the by the users. And there are some security control that is also available for the system maintenance. If these controls are available in a perfect manner, then only the system will be reliable. But if the design fails to specify them, that means we are okay with the requirements, we are okay with the analysis. If we, at the third phase, that is the designing phase, if the system fails, so that allows the loss of the funds or the merchandise for a lengthy time before someone detects the problem. The system is not reliable. So reliability at a design level is possible only if the analysts perform a thorough and effective determination of the system requirement. So everything is starting from the requirement. Every we can say the take and give rule is taken or determined from the requirement. So requirement is one of the main stage. So if that captures or if the requirements are captured very well by the system analyst, then there is no problem in any phase. And if the problem occurs, that there is a communication gap in the requirements only. So the most important role of the analyst to perform a thorough and the effective determination of the system requirement. A careful, thorough system study is needed to satisfy this aspect of reliability. The next one is the second level of system reliability involves the actual working of the system delivered to the user. That means what are the various systems that is delivered from the system, what are the various reliability concepts that involves the actual working of the system delivered to the user. At this level, system reliability is interwoven with software engineering and the development. And when the error occurs, so error occurs whenever the system does not produce the expected output. For example, if I give the exam, and I expect at least 40 marks out of the 50, but I cannot get the 40 marks out of this 50. That means there is some error in the requirement, there is some error in the writing, there is some error in the formulas, whatever. So we have to debug, we have to evaluate the problems, re-evaluate the exams. In the same way, errors occur in a system and the system does not produce the expected output. That means we expect something different, the output will be something different. But it is also true that the no program is ever fully debugged or fully tested nor proven correct. So errors are not limited to the correct use of programming syntax alone. So this is not that errors will occur only in the coding part. No, error will occur at the analysis phase, the designing phase, whatever the phase. Now next one is the error avoidance. How we can avoid the errors. Now there are three approaches of the reliability as we have studied in the index. That is error avoidance, error detection, and the error tolerance. So one is we have to avoid the errors. The errors will not arise to maintain the quality assurance. If the errors occur, then how to detect the errors? And if the errors are detected, then how to remove the error, that is error tolerance. So this is given over here. Under the error avoidance, developer and the programmer make every effort to prevent the errors from occurring at all. That means the error does not occur in the programming, in the system analysis, design, or the implementation phase. But in case the errors arise, so focus on the developer phase. So emphasis on early and the careful identification of the user requirements. In another way, the objective will be pursued. And the analyst must assume that it is impossible to fully achieve this objective because error will occur despite the best efforts of every person, every analyst, every developer, anyone. So how to detect the error and how to correct the error, that is the next part. So you tell me that how to correct the errors. So we have avoided the error, but unfortunately the error will arise. So how to detect the error first of all? Anyone can answer? Yes, very good point. So one of the error detection is there is a misspellings or there is a spelling mistakes in the programming or there is a spelling mistake in the report writing. What else? Yeah, there's a syntactic errors. Very good. Then yeah, there is a yes, semicolon is missing. That is also syntactic error. Anything else about the apart from the coding error? Hello, hello. So the next part is error detection and the correction. How to detect the errors. So we have discussed about the how to detect the error. First one is misspelled keywords, misspelled words, or entering the invalid commands is one of the factors that we have to detect the error. That if there is a misspelled word or if there is an invalid commands. This method uses the design feature that can detect the error and make the necessary changes to correct either the error while the program is in use or the effects on the user so that a failure does not occur. And correcting user's error or user error such as misspelling keywords or entering the invalid commands in one of the remedy. And the error detection in program is handled in a similar manner that is used by the analyst or the tester. For example, a programmer that calculates the productivity of a waiter or the waitress in a restaurant by dividing the revenue from the meal served into the hours work should not fail when the employees do not serve anything. And when a blending snowstorm prevents a customer from coming to a restaurant, employees will accumulate the working time uh, but will not have the sales. That means there is no sales that is available for the employees for finding the snowstorms or snowstorms. And this program should take the divide by zero error and correct for it in order to keep the system running properly. But unfortunately, many program fails when a conditions like the this one occurs, even though it may not happen for many years, but sometimes the error will occurs. So the failure occurs later. Then next is error tolerance. That is how we can tolerate the errors. So that strategies keep the system running even in the presence of the error. That means we have tolerated the error. If there is error, that it's okay. We have to move on to the errors. We have to move on to the systems. So keep the system running even in the presence of the errors. And the NASA, that is the National Aeronautic and the Space Administrations, for example, design its system to be error tolerant through the use of redundant hardware. Then there are some errors that is due to duplication of the hardware. In one case example, duplication on the board computer and the computer voting are used to process the data in the parallel, so the results can be compared. The results can also be compared in the board computers and the computer voting. Two computers process the data on the location, course correction, and compare the results with those produced by two other computers. So another manner of the error tolerance is the use of the degraded processing. That is how we can degrade the processing. What are the various methods to degrade the processing? And with this strategy, the user receives less service than the system was designed to provide. So what are the various systems that the user services or less services that the system was designed to provide, but that is considered as a better alternative in some cases than having no service at all. For example, many electric power generation and the distribution facilities in America are computer controlled. Now, for example, if there is a hot day, the system will be overloaded and the computer control center is unable to correctly process the location data and keep up with the power demands. So the demand is high, so the computer control is not capable of doing or correct the processor location data. Rather than taking the risk damaging the power distribution network, the computer automatically shut down the parts of the network. So the computer automatically shut down the parts of the computer for the power distribution network. And by providing the degraded service, the computer tolerates a software error without any failing. So this is one of the example how we can tolerate the errors or why. Now, next one is what are the various causes or what are the various factors that cause the errors. So the software aspects of the system design are different from the concern about the hardware reliability. In hardware, for example, any design errors that are reproduced in every copy of the item manufactured. However, application systems are often unique and design errors are not widely distributed. So whatever the application system, whatever the application area that is unique and the design errors are not widely distributed. And of course, if you're working on a system that will be sold commercially, there is considerable concern over the development and the marketing of the software packages that is rammed with the system or design errors. The system aspect or the software aspect of the system design are different from the concern about the hardware reliability. And the manufacturing errors are also introduced during the actual production or actual production process. And they are not a property of the design and in fact may not be in every item produced. And manufacturing the errors may exist only in the items that is made during a specific time period, either because of the unknown problems with material quality or the mistakes. Next one is a hardware failure that occurs when the equipment is used, or that equipment that is used that begins to wear out or outdated, and there is no equivalent in the software. For example, using the processor with the old capabilities, then we have to find the new hardware that is usable with that we have to find out the new software that is used with that hardware. The medium on which it is carried, for example, magnetic tape or the disk may become worn or damaged, but the software will not. Therefore, the primary software problem is designing and developing the software that will not fail. Now, what are the various causes of error that enters the analyst? So what are the various phases or what are the various causes that is relevant for the analyst? So these phases that is relevant for the analyst, that is taking out the right decision at the right time, not obtaining the right requirements. So for one of the main error that is taken out by the analyst, that not obtaining the right requirements from the users. Then not getting the requirements right. Same point, then not translating the requirements in a clear and understandable manner so that the programmers implement them properly. So there is no guidance that is given to the analyst, or the analyst will know is not capable of clearly understand or clearly explain the manners or explain the requirement that is given by the users to the programmer so that the programmers can implement them properly. So the main fault or the main cause of error is from the analyst point of view. First is not getting the requirements right. There may be communication gap between the user and the analyst, or there is a, we can say there is a telephonic conversation between the user and the analyst. There is a face-to-face, and if the requirements are not gathered properly, that may be n number of reasons. But the main concern is that not obtaining the information correct. Next one, not translating the requirements. Once the requirements have been gathered from the users, the next role of analyst is to supply that requirement, or pass that requirements to the programmers that implement them. Yes, it's also the responsibility of the system analyst because he is a concerned person, he or she is a concerned person over there. So next is, there is also error if the analyst does not translate the information, does not translate the requirement in a clear and understandable manner so that the programmer implements them properly. So that there is a requirement so that the programmer can implement them in a proper manner. And the transition from the system design to software development is an additional opportunity for introducing the translation errors. And there are also the results of the programmer that not properly understand or interpret the design specification that is produced by the analyst. For example, the analyst have also the opportunity, also have a facility to write the requirement to the programmers in case there is any spelling mistakes, in case the requirements have been forgot to write in the notes. That is also the case in which the errors occur. So these are the results of the programmers not understanding the requirements properly written by the analyst. In the same way, there is also the fault from the programmer's end. If the requirements are correct, okay, verified, and it is a written document by the analyst, In case the programmer does not able to translate that specification into their own terms, into their own coding, into their own requirements. That is also the case, but that is the programmer's fault, not the analyst's fault. But this is the rare case that is able to, that we are getting to find out, because the programmers can gather the requirements and make the fruitful efforts for making the program. But the main concern, the main error is from the analyst point of view. Yes, in case the programmers, yeah, listen, in case there is a programmer error, the programmer is forced to make the design or design the decision while coding the program. That is a programmer error. He or she have to again recode the program, again recode the main system, and make the design within a time budget, within the time limit. And when such misunderstanding exists and implementation occurs before they are detected, the result is a need for the maintenance. That is not that everything is again carried out. But if the requirements are correct, there is error in the coding part. That coding will be improved by making the maintenance phase that we are going to study in the next class, that is in the tomorrow's class, that is how to maintain. But till now, you understand that if the requirements are not gathered correctly, that everything is failed. But if the requirements are gathered correctly and there is a problem in the designing phase, coding phase, then there are issues, but less issues than the requirements stage. What are the issues? That is resolved by the maintenance, that is resolved by the system maintenance. So yes, maintenance part we will take out in the next class and in tomorrow's class. So till now, any doubts, anyone? Any clarification regarding the quality, system control, quality assurance? Everything that we have studied in the today's class is for the system control, for the system, we can say the error tolerance, or the, how to remove the system. In the next class, that is in tomorrow's class, we will study that if the errors occur at the maintenance, at the programmer's code and the programmer's end designing phase, so how to maintain them. So that's all for today's session.